Before my talk, let me introduce myself to you briefly. My name is Takashi Norimatsu, working at Hitachi Limited Japan. Also as key clock maintainer. Key clock is identity and access management open source software. I've been implementing and contributing some promising features to this key clock. For example, W3C web authentication API support to key clock, and financial grade API security profiles support to key clock. One of the main topic of today's my talk. Today, I would like to talk about the following items. At first, I'd like to talk about what open banking using OSS2 authorization protocol is. Then, how we can access API of open banking securely, namely by applying financial grade API, FAPI security profiles. And I would like to tell you the actual open banking that applies FAPI security profile in the real world. Then I'd like to briefly describe how this FAPI security profile secure API access, namely describing the mechanism of securing API access by applying FAPI security profiles. Next, I would like to pick up the open source software that actually implements FAPI security profiles, namely Keycloak. Finally, I would like to talk about, describe briefly how this Keycloak support FAPI security profiles in a flexible manner. So let's move on to the first item. What open banking use OSS2 protocol is. There are several kinds of open banking use case or similar use case. For example, the payment services by using QR code, two-dimensional quick response code. That is very famous in Japan. But however, today, I would like to pick up open banking using OSS2 authorization protocol. This protocol is defined by RFC 6749. In this open banking use case, the end user of financial service provider want to access financial services provided by this financial service provider. In order to do that, end users uses third-party client application. This client application access API provided by financial service provider to receive financial services on behalf of an end user. To realize this use case, OSS2 authorization protocol is used. But however, only simply using or applying OSS2 protocol is not enough to realize secure API access in open banking use case, because this OSS2 protocol is very flexible. Therefore, if we may use improperly, we may introduce security holes for this open banking use case. To prevent such problem, the OSS2-based security profile is generally applied. This security profile describes how to use OSS2 authorization protocol securely in such use cases. So next, I would like to talk about such the security profiles namely financial grade API, FAPI security profiles. FAPI security profile is OS2-based security profile standardized by OpenID Foundation. That is standardization body for digital identity, for example, OpenID Connect and so on. There are several kinds of FAPI security profiles. And the following, the FAPI security profiles, first two security profiles are very important. FAPI 1.0 Part 1 baseline and Part 2 advanced. These two security profiles have been finalized, while other three FAPI security profiles are in still draft version. The FAPI 2.0 security profile is the next version of FAPI 1.0 baseline security profile and advanced security profiles. Then you may have the question about the security of FAPI security profiles itself. Whether the FAPI security profiles are theoretically secure or not. To answer this problem, the several security analyses for FAPI security profiles have been conducted. Those security analyses found out some security problems included in draft version of FAPI security profiles. Therefore, the OpenID Foundation fixed these security problems and released the final version of FAPI 1.0 security profiles. Therefore, in my opinion, it might be okay to say that FAPI security profiles are secure. Then the next question is, if we implement FAPI security profiles to our software product, whether such software product complies with FAPI specifications or not. To answer this problem, OpenID Foundation provides conformance test suite for FAPI security profiles. Therefore, we can, by using this conformance test suite is published as the open source software. Therefore, by using this conformance test suite, we can check out whether our product that implements FAPI security profiles actually complies with the FAPI security profiles. And also, OpenID Foundation provides certificate program. The OpenID Foundation certifies the software product that complies with FAPI specifications. Then OpenID Foundation publishes the list of such software products in their website, in this URL. So next, I'd like to talk about the open banking use case that actually applies FAPI security profiles in the real world. As far as I know, there are 3 such open banking use cases. UK open banking, Australia consumer data rights, and Brazil open banking Brazil or open finance Brazil. These 3 security profiles applies FAPI 1.0 advanced security profiles as a basis of their own security profiles. The UK open banking and the open banking Brazil also applies the FAPI SIBA security profiles. Therefore, the FAPI security profiles are actually used in the real world. So next, I'd like to describe the mechanism of securing an API by applying FAPI security profile. To do so, I would like to consider the situation that we uses only OS2 authorization protocol for open banking. And I would like to, by using, in this use case, there are several kinds of security problems may arise. So I would like to pick up 3 of them and also describe how to resolve these problems by applying FAPI security profiles. First problem may arise in front channel communication. According to OS2 authorization code flow, at first, client application send authorization request to authorization server via end user's browser by HTTP redirect. Then, it seems relatively easy to tamper or modify force this request compared with direct communication between client application and authorization server. To prevent or to resolve the problem, FAPI security profiles describes using digital signature for message integrity and authentication for this authorization request. To say more precisely, FAPI security profiles describes using request object defined by RFC 9101 and OpenID Connect Core. This request object is the JSON Web Token JOT that can include the contents of authorization request. It can be signed and optionally it can be encrypted. And another solution is to avoid front channel communication. FAPI security profiles describes sending the content of this request directly from the client application to authorization server. To say more precisely, FAPI security profiles describes using pushed authorization request called PAR, defined by RFC 9126. By following this PAR, the client application can send the content of authorization request directly to authorization server. Next problem, second problem may also arise in front channel communication, but however, in authorization response phase. According to OS2 authorization code flow, client application, authorization server send back to the client application authorization response via end user's browser by HTTP redirect. Therefore, it seems relatively easy to modify this response compared with direct communication between OS server and client application. So the FAPI specification describes using also digital signature. FAPI specification describes using ID token defined by OpenID Connect as a detached signature by leveraging OIDC hybrid flow instead of authorization code flow. This ID token is JOT, and it can be signed, and also optionally it can be encrypted. Or another solution is JOT secured authorization response mode for OS2 called JAM. JAM is one of the FAPI security profiles. This JAM is also the JSON Web Token that can include the authorization response parameter. It can be signed and optionally it can be encrypted. The third problem may arise if when the client application tries to access API by using access token in bearer token usage. RFC 6749 OSS2 protocol does not describe how to use access token when client application tries to access an API. Then instead of that, RFC 6750 describes how to use an access token for accessing an API called bearer token usage. By following this bearer token usage, everyone who has an access token can access an API. Therefore, if an attacker steals the other access token, then this attacker can access an API illegally. To prevent that problem, the FAPI specification describes using sender constraint token instead of bearer token. By following sender constraint token, only the client application who received an access token from an authorization server can only access an API by using this access token. The FAPI security profiles describes using OSS MTLS defined by RC 8705 for realizing sender constraint access token. By following this OSS MTLS, the access token is bound with client application's client certificate by leveraging mutual TLS. Therefore, someone who has this access token wants to access an API, then they need to prove that they are a holder of client certificate. To say more precisely, the holder of private key corresponding with this client certificate. Then another solution is DPOP, OSS2 demonstrating proof of possession at the application layer defined by Internet Draft. By following this DPOP, the access token is bound with client application's private key. Therefore, if someone who holds an access token wants to access an API, then they need to prove that they are the holder of this private key bound with this access token. The next, I'd like to briefly talk about open source software that's already implemented to FAPI security profile, namely Keycloak. Keycloak is open source identity and access management software. It supported several kinds of features, for example, single sign-on, accessing API, securing API access, and authorization service, and so on. Also supports several standards, OpenID Connect, SAML-v2, WebAuthn, OSS2, UMA2, and so on. And so I and the Keycloak community called FAPIscene member and also other contributors implemented and contributed FAPI security profiles to Keycloak. And as a result, the current Keycloak have supported the following security profiles: FAPI 1.0 baseline, FAPI 1.0 advanced, FAPI CIBA, Brazil Open Banking, Australia CDR, UK Open Banking. Among them, the OpenID Foundation Keycloak was certified as the software product that complies with FAPI 1.0 advanced and FAPI CIBA, Brazil Open Banking, Australia CDR by OpenID Foundation. Finally, I would like to briefly describe the mechanism of supporting FAPI security profiles in Keycloak. Keycloak uses the concept of client policies to support FAPI security profiles. Client policies is a policy-based method that consists of two parts, profile and policy. Profile is actual implementation of security profiles like FAPI 1.0 baseline, FAPI 1.0 advanced, while policy is logic for determining which request from the client application applies which security profiles. These policy and profile can be implemented as plugin to say more precisely provider in Java by leveraging Java's service provider interface (SPI) mechanism. Therefore, you can implement your own security profile or your own policy by this profile without modifying Tcloak's body source code. Therefore, I think it's very flexible and customizable for supporting security profile. This client policy and profiles can be represented as the JSON format like that. For example, today I've talked about the following items: what open banking using OS2 is, and how we can access the API open banking securely, namely by applying FAPI security profile, and actual use case of open banking that uses FAPI, and also the mechanism of securing API access by applying FAPI security profiles. And also, I've picked up the open source software that implements FAPI security profiles, namely Tcloak. Tcloak supports FAPI1 baseline, FAPI advanced, FAPI CBA as built-in profiles. You can use these three profiles as a default. And Tcloak was certified as FAPI1 advanced, FAPI CBA, Australia CDR, and Open Banking Brazil FAPI 1.0 supported server by OpenID Foundation. Finally, I'd like to briefly describe the mechanism of supporting FAPI security profile in the Tcloak. Okay, that's all for my talk. Thank you very much for your listening.